Go. Can colorblind glasses help a baseball hitter differentiate different pitches? So the reason I picked this topic is because colorblind glasses are supposed to enhance red and green. And so as you can see here, the seams on a baseball are red. And so maybe it would help enhance the red for the hitter. So colorblind glasses use reflection. And so what reflection is when like a wave encounters a boundary and it bounces off. Some of it transmits through and some of it bounces off. And the wave coming in is called the incident wave, and the wave bouncing off is called the reflected wave. And the angle of the incident wave is always the same as the angle of the reflective wave, and that's called the law of reflection. And so here you can see that the light waves coming off the object bounce off into the eye of the person. And you can see that also in this picture with the painting, and that's why we can see things. So here is a simulation. And so here you can see with no lights, it's just black. And then when you put the red light into the eye, it becomes red. But then when you put red and green together, it actually gets yellow. So your brain can actually only see these three colors, red, green, and blue, but they just combine together to make different colors. So all three together make white. So that relates to how the eye sees color. So basically in the back of your eye and your retina, you have rods and cones. And so what rods do is they're for like low light detection and like seeing in the dark. So that's why you can't really see colors as well when you're in the dark. And then the cones are for seeing different colors in the light. So with the cones, you have cones that can only see blue light waves, cones that can only see green light waves, and cones that can only see red light waves. And so, as I showed you before, those combine together to make different colors like yellow and purple and white. And so, with a colorblind person, they might have less cones than a normal person. And so that's why they can't see red and green as well. And so this is like what they would see in like a vegetable aisle, because a lot of it is red and green. And the reason why red and green are usually like what the brain is confusing is because, as you can see here, the light waves for red and green cones are very similar, like almost identical. And so the brain confuses them very easily if you don't have the right amount of cones. And so here is a colorblind test. So if you can see all the numbers, then you're not colorblind. And so I'm going to pass around some blue film, and it should make all of the, like most of the numbers go away, because it'll just make it look different. So how do the colorblind glasses work? Basically what colorblind glasses do is they use reflection. So like the way they use reflection is they bounce off light waves like yellow or like blue, for example, because that's what's making you like confuse it more. And it lets more red and green light waves come through so that you can differentiate red and green better, like by using the glasses. So related more to the experiment, here's the like brain processing time. So it takes the brain 0.1 seconds to process that a baseball pitch is coming, and 0.13 seconds to register color. So about the same. And so here, this is how fast the ball is moving. So for my experiment, I picked a fastball and a changeup because coming at the batter, they look very similar. So the fastball takes around 0.5 seconds to come from the pitcher's hand to home plate, and the changeup takes about 0.7 seconds to get from the pitcher's hand to home plate. So my hypothesis is that the glasses will work because they're supposed to enhance red, which I believe that should make it easier to tell the difference. So again, like The reason why I picked these two is that they look very similar coming in to the batter. As you can see here, like it's just white and then like a little brownish white, but they're actually very different. The fastball is significantly faster and the changeup is slower and also drops down at the end. But so what I did was I had one batter who wasn't colorblind at all and one batter who was slightly colorblind, and I had each of them see a mix of these two pitches, 10 with the glasses, 10 without the glasses, and then I recorded the data. So here's the data. Here, where it says guess, that's what they guessed the pitch was, and where it says pitch, that's what pitch was coming in. Where it's green, that's when they got it right, and where it's red, that's where they got it wrong. So this one right here, that's the colorblind batter. Without the glasses, he got 6 out of 10 right, and with the glasses, he got 8 out of 10 right. While the batter who's not colorblind, without the glasses, got 9 out of 10 right, and with the glasses, got 7 out of 10 right. And also, the FB is for fastball, and the CU is for changeup. So in conclusion, obviously for people who are colorblind, the glasses did help, especially with the results from the data where the partially colorblind batter got significantly better with the glasses. However, like for the batter who was not colorblind, they actually made him worse, meaning my hypothesis was wrong.